So the Arduino programming language is a simplified version of C. Don't be scared though, if you're not a C programmer, you don't have to know a lot of the more esoteric, quote unquote, harder parts of C. References and pointers are there, but you generally won't have to use them unless you really dive down deep into the hardware. The subset of C that you're going to use is going to look to you, I think it does to me at least, more like Java or C# or JavaScript. It has that basic C syntax, but it's not C, right? It's a specialized language, simplified, geared towards the kinds of things that you'll need to do with the hardware, not geared towards writing expansive C low-level programs. Now the basic syntax, again, if you've written in any C-derived language, single-line comments, double slash, multi-line comments, slash, star, star, slash. Curly braces define the scope of functions and control structures like ifs and whiles. Every single line of code has to have a semicolon at the end. Hash include brings in a library header file. We'll talk more later in this module and in the course about libraries. And hash define defines a constant that gets replaced during pre-processing with the actual value of the constant. In terms of data types, again, things that you would expect, no real surprise. We've got Boolean, true, false, char, string array, or char array, arrays, doubles, floats. So the typical kind of data types that you'd be used to. Now, one thing that you might want to think about doing is using the smallest data type possible. Probably most programmers today don't follow that rule because we tend to have 32, 64-bit processors and large amounts of memory. Because of the size of the Arduino, if all you need is a byte, you should use a byte instead of an int. If all you need is an int, you should use an int instead of a long, etc. But this is pretty much the basic data types you'd expect from a C-derived language. Now, string is a little different. There is char array, so that's like an array of characters, and that's a string. But there is also capital S string, and this is an object that's part of the language. It's written and put there to make things easier, more in line with other modern languages like Java or .NET. So we've got the quote-unquote old string, which is an array of characters. And then we have the new style string. So we have things on that like to lowercase. So whether you use char arrays or strings just depends on what you're going to need to do with those strings. No real performance or size difference between the two. Again, operators you would expect. This is not an inclusive list, but a quality assignment and or not. Again, there is the ampersand and star, which is the reference and dereference operators. But again, unless you're going down deeper, mostly what you're going to be using is the operators that you normally use, adding numbers, subtracting, dividing, modulo, equality assignment. You can pretty much ignore the fact that reference and dereference operators are there. The API space for Arduino and Arduino devices isn't going to force you to use things like references and dereferences. Again, only if you get into the deeper levels of building your own hardware or wanting to interface more directly to the hardware would you ever have to use anything like that. So you have the typical flow control that you'd expect in a C language. We have if else, for, switch statements, while, do while, break, etc. In terms of flow control, the flow control of the overall sketch is determined greatly by the loop function. Remember the loop function, and we'll talk more about the loop function, executes over and over and over and over again. So that in and itself is a method of flow control. And there's also functions for delaying time and finding out about time. So delay and delay microseconds. Delay is milliseconds, delay microseconds, obviously microseconds. These are often used, whereas in a normal programming language, in a normal application, let's say, it would be unlikely you would ever use a delay sort of function as part of your normal program. When you're working with hardware, you definitely might want to, because you might want to wait for something to happen. And if you don't wait, everything could pass by way too fast. You'll see that in the demos. And if you've already watched the first module, you would have seen it in the first demo as well.